everyone, welcome to Duodecimal Division. My name is Eric Larson and this is the third video in a series of videos that I'm calling Secrets of the Numerals. And in these videos I'm revealing to you some of the hidden meaning and symbolism within the various numerals. And so in this video we're going to look at the numeral that represents the number 3. So if you're following along, you already know that we are looking at a base 12 grid and that the people that created these numerals were using base 12 math and specifically base 12 geometry to come up with these various symbols. And basically base 12 geometry means when you're doing your geometry on an XY coordinate plane or a Cartesian plane, there's 12 little squares in between your 1 and your 2 and your 3, basically in your bigger squares. So you're working in groups of 12 and you're breaking up your 1 into units of 12ths. Okay, so the reason I'm really focusing on that right now is because the numeral that represents the number 3 has got some math in it, and the fact also that we're going to be using a geometric pattern that only really has significance in base 12. It's a shape that's a dodecagon. I introduced it to you in the introduction to this series of videos, and we're going to be using that shape to define the shape of the numeral that represents the number 3. So first thing we're going to do is go to the third circle in the series. That's the circle with the radius of the square root of 3. And we're just going to see where it fits on the grid. And actually, the first two circles that we were using had lattice points that define the radius of the circle, but the square root 3 radius circle has no lattice points. There's no spot where horizontal and vertical lines are intersecting and the square root of 3 lands on those points. It's actually going between. No matter how fine of a grid we create on the Cartesian plane, the square root of 3 radius circle is always moving between the lattice points. So what we're going to do is go to one of the points that's defined by this series of overlapping circles that we generated at the beginning of this series of videos to create all these degree lines. And we're going to use one of those points, start there, to see what kind of pattern will evolve out of the various lines that we have to work with. So what we're going to do is go to this point right here. I'm going to count out 1, 2, 3. So here's the third ring in the series, and I'm going to just make a mark on that point right there. Okay, so that's one of the points where the overlapping circles overlap. I'm also going to make a point right here in the center of the circle just to reference those 2 points, because what I'm going to do now is flip my board around, because on the back side I have the same pattern, but instead of all these circles I have the dodecagon that I introduced to you, and we're going to use that, like I said, to generate some of the lines for the numeral 3. Okay. Alright, so the same series of lines, but a different same series of circles, but these lines are not the 30 and 60 degree lines, but this is the 45 degree line, and these are the dodecagon lines. I think you can just see the dodecagon shape underneath this pattern. So this particular point here now on the dodecagon does have a very specific lattice point. That's one of the qualities about the dodecagon, is that all of the lines are very firmly placed on the Cartesian plane. So all of these lines have the slope of either going over 1 and then up 0.7 or up 1 and over 0.7. So we're going to be looking at this line here. You can see the one that has the point on it. That's the slope, that's the line that we're going to be using to start with our diagram. But even before we get to that, what I'm going to do is just trace the arc of the circle. I'm going to do half of the circle of the square root 3 radius. So let's just start with that. Basically where that point is, and then just go around like this. And I'm going to go to that point right there. Okay, so I'm going to trace half the circle, and I'm going from the point where this line is intersecting the square root 3 radius circle to this point here. So I got a half circle, and now I'm going to go to this point, and we're going to find out what the coordinates of that point are. So we're going to go up 1 and over 7, then we're going to go up 0.6, so half of that, and so and then over half of 0.7, which is 0.36. So I'll just write that here. We're going to go 1.7 plus 0.36, so 789A. So point A6 is the x coordinate, so I'll just write that down right here, point A6, and then the y coordinate was 1.6. 1.6. Okay, so let's just figure out where that is in relation to the square root 3 radius circle. So I'll just draw a little triangle over here. I'll just apply the Pythagorean theorem. A squared plus b squared equals c squared. So this will be our c side. So the height of that is 1.6. And the bottom part, or the b, is going to be point A6. So 1.6 squared is 2.3. And point A6 squared is 0.923. So we're going to add our a squared and our b squared. So 2.3 added to 0.923 gives us the answer of 3.023. So our c is going to equal the square root of 3.023. Okay, so far so good. So we can see that that point here is just outside of the square root 3 radius circle. So now what I'm going to do is start from that point there and just follow the line up, tracing it again to this point right here. Again, a lattice point, and its coordinates, that's basically halfway, so we're going to do another half, and then over 0.36, and then up 1 and over 7. So 3 times 0.7 equals 1.9. So the x coordinate is 1.9, and the y coordinate is 3. And now we're going to draw a line going straight along the top here, this horizontal line of 1, 2, 3. So now we have the length of 3 again. We have the length of 3 from the x, or from the y, or the x-axis, 1, 2, 3. Then we have a line here, the length of 3. So this coordinate point here is negative 1.3 and 3. So we have a lot of 3's are appearing in the coordinate points of the numeral that represents the number 3. And basically that's it as far as the numeral, what it looks like. We have a bar on the top, then this angle, and then down, and and then the half circle. So there's a lot of similarity actually to the 2 in terms of a flat. It's just like upside down though. We got a flat line, an angle, and then part of a circle, kind of like I say, upside down version of the 2. So let's just look at all the different parts that we have, or all the different lengths of the lines. We've got the 3, and we also have the decimal version of the 3. If you look here, 1.9 is 0.3 from this spot here, and we have the 1.3 is the coordinate here. So it's like this 3 length line is sort of, instead of sitting right on like the 2 and the -1, it's been moved over 0.3. So I'm going to just put 0.3 down here. My pen's running out of ink a little bit, that's okay. So 3, the 0.3, I'm going to write square root of 3.023 just to add to our list of relevant points and everything. And then we also have the distance from this, basically the diameter of the circle, which is 2 root 3. And just as an aside, in base 12, 2 root 3 is the same as square root of 10. 2 squared is 4, and 4 times 3 in base 12 is 10. And I think basically that is it. So we got the coordinate points of those 2 here, and then this point is where the line crosses. The dodecagon line is cutting that circle in half. I'm going to put the whiteboard behind so you can see all that. Okay, and I just thought of something else. For the 2, I was showing you the sort of the relationship of pi and this part circle. So we can do that also. We know again the circumference of the circle is 2 pi r, and this radius is the square root of 3. So 2 pi times the square root of 3 divided by 2, because this is half a circle. So we cross out the 2's, and the this length of circle of circumference is basically square root of 3 times pi. So I'm just going to put this down here also, because we're just kind of looking at all the 3's that are contained within this numeral, sort of the hidden secrets about this particular numeral. So I found that this numeral shows up a lot on barcodes. Maybe it's the flat top and then the half something about it. It's used there a lot, but you can see it around. I think perhaps the other version with the 2 circles is a little more common. Maybe that's because of the digital age now, and you see that shape in traffic lights and on digital clocks and that kind of thing. I think this is the original version. I think that's the way it was originally created. You can see all the 3 that's in there. And again, it's a base 12. This is all base 12 math. And it's a base 12 symbol, the dodecagon, that creates that line and that angle. So there you have it. That's why the numeral 3 looks the way that it does. I hope you enjoyed this presentation. And now we're going to go to the next video where we're going to see why the numeral 4 has its shape and what type of geometric information is hidden within that particular numeral. So I hope you can join me for that. Thanks for watching.